So let us look into proving the half identities, half double identities, or deriving the half identity. So let's start with the sign 2. Can I use theta? Let me use theta. It can be x, it can be a. Therefore, it's equals to 2 sine theta plus times cos theta. So let's say we want to prove the half identity, or maybe let's say we want to prove the sine half, sine half. So what we're going to do, let's say for an example, we assume that maybe one of the angles is half. One of the angle is half. So let's say we want to halve theta. So let's say we say sine, let's say we want to halve theta. When we halve, it means that we are dividing by 2, isn't it? So half theta. So what is going to happen? On the other side, we do the same thing because when we substitute theta, we halve theta. So we have theta over 2 times cos theta over 2. So in that case, then if let's say, for example, you simplify, you know that, oh, sin theta in some other cases, sin theta, these two multiplies each other, will have theta. Then sin theta in some cases is equals to 2. We'll have sin theta over 2 times cos theta over 2. So if you want here, you can make one subject with the formula, you divide on both sides. You'll have maybe sin half theta. It is equals to 1 half sin theta over cos theta over 2. Theta over 2. So in that case, that's how we do the halving of the angles. If you half on the left hand side, you half on the other side. So for another one, when we want to know what is maybe sin theta or cos theta, we go to the double angle identity. So let me use the sin 2 theta. Let's use the one of 2 cos squared theta minus 1. So the cos 2 theta equals to 2 cos squared theta minus 1. So let us prove. So if we have theta on this side, we'll have cos theta, isn't it? Therefore, it's equals to 2 cos squared. Therefore, we halve theta, therefore minus 1. So we halve theta on the other side, we halve it on the other side. So because when we're substituting theta, if theta was 20, even it was 20. If we have halved it, we have half and half 20 there and half the 20 on the other side. Now we need to make the one with the half subject of the formula. How will we do that? We're going to take 1 to the other side. It's going to meet with cos. So I'm going to have 1 plus cos theta is equals to 2 cos squared theta over 2. Now what I'm going to do, we want to get rid of 2. So I divide on both sides of the function by 2. So when I divide it by 2, we will have, so it's 1 plus cos theta over 2 equals to cos squared theta over 2. So we want to get rid of the square. How do we get rid of the square? We apply a square root, isn't it? So applying a square root, we'll know that we'll have cos theta now over 2 equals to, putting a square root of plus or minus, we'll have plus or minus 1 plus cos theta all divided by 2. So that is our half identity. So cos theta over 2 equals to plus or minus root 1 plus cos theta over 2. So that's how we prove it. So sometimes when you see that you're having a half identity, where does it come from? We have half the double identity. The cosine to be plus or minus 1 plus cos theta over 2. So same thing, what if we want to prove the one which consists of 1 minus 2? sine squared theta cos 2 theta equals to 1 minus 2 sine squared theta. We do the same thing. Let's halve the angle. Halving dividing by 2, the angle dividing it by 2. So we'll have cos theta equals to 1 minus 2 sine squared. We halve the angle, so theta divided by 2. From there, let's make sine squared subject of the formula. So I hope you see sine squared is negative. Take it to the other side, it's going to be positive. 2 is going to be 2 sine squared theta over 2 equals to 1. Take cos to the other side. It's going to be minus. It's going to be minus. It's going to be minus cos theta. So we take cos to the other side is negative. Take 2 to the other side, it's going to be positive. Let's divide by the 2 here. It was 2 here. Divide by 2 on both sides. You'll have over 2. Divided by 2 on both sides of the identity. Now we want to make sine subject of the formula. We get rid of a square by putting a square root of plus or minus. So square root of plus or minus will have 1 minus cos theta over 2. So root of 1 minus cos theta over 2. Root of is theta over 2. Okay, obviously we are improving our half identities. Proving our half identities. Okay, in just maybe 6 minutes, where will you use this? Let's say you want to find solutions of angles. Let's say we're given 1.1 is equals to sine 15 degrees. We have sine 15 degrees. We need to determine the following without the use of a calculator and by using the half angle identities. But if it was not specified, you'll have to try and figure out again without the use of a calculator. Remember when we're doing the cos 105, we had to add the special angles or the vertical and the special angle, horizontal with the special angles. So using half identities, we need to try and inspect which special angle that you can half and get 15 degrees. That's how you ask the question. Which special angle can you have to get 15 degrees? So which means we can express this as sine 15 over sine 15 degrees over 30 degrees to say sine 13 degrees over 2. So sine 30 degrees over 2. It still gives us what? 15 degrees. So please express it in this way that, oh, I have half of theta. Theta is what? 30 degrees. So theta is 30 degrees. The angle is 30 degrees. The one that we have halved. So luckily we just proven the half identity there. We have theta half, which means moving to the other side, we have theta half is equals to plus or minus root 1 minus cos theta over 2. So therefore it is equals to. So this, when you substitute the plus or minus into root, it will be 1 minus cos. So we said theta is 30 degrees. So theta is 30 degrees. Then all divided by 2 without the use of a calculator. Let's simplify. Therefore, it will be equals to. So without the use of a calculator, direct to get the cosine of a function. So I'll have minus. From the special triangle, what is From the special triangle, what is cos 30? Special triangle. What is cos 30? This root is root 2 over, root 3 over, root 3 over 2. Then everything is still divided by 2. We have simplified without the use of a calculator. So expressing it fully or simplifying fully, you can add fractions inside the root. So I'm adding fractions, I'll get 2 minus root 3, all divided by 2. Let me put this division there. 2. But we're not using a calculator, so everything was still divided by 2. So these 2, I said, let it divide in this format while I've added fractions in. So 2 minus root 2, 3 over 2. So changing this to division to multiplication, 2 goes down, and it makes 2 that multiplies up. So I have 2 minus root 3 over 4, because this goes to the denominator and multiplies with 2. So we get 4. So we didn't use the calculator to get the answer directly. But if you recall the rules of sets, the one that we applied the other day, we know that the numerator shares the square root with the denominator. So if we are having division, we can have 2 minus root 3, all divided by root 4. What is root 4? It is 2, isn't it? Root 4 is equals to 2. So hence, when you use your calculator, it gives you this. In fact, when you say sine 15, what does it give you? But that's the answer that you must get without the use of a calculator. So sine 15 degrees is, so it is, okay, so it has simplified the root inside it. It's multiplied, which is the 2 minus from 3, but still the same answer. And if you have used a calculator, that's what we'll see. You get that root 3 minus, is it root 2? Yeah, is it root 2? Yeah. Using a calculator, that's how we see. But if without the use of a calculator, applying the double angle half identities and special triangles, or special angles to say, and additions of fractions, and knowing the sets here, splitting the numerator and denominator. That is the answer without the use of the calculator. Okay, I hope that is clear. Perfect. Okay, just want to put one last one in. Moving on, put tomorrow. So let's say we have cos 22.5 degrees. 22.5 degrees. So we need to determine the following without the use of the calculator and by using the half angle identities. So again, you ask the question, which special angle can we divide to get 22.5? So it is cos 1 over 45 degrees, isn't it? So it's 45 degrees that we can divide by 2 and get 22.5 degrees. But that's the special angle. So sometimes our advice, maybe you can even express it using the, what do we call? You can just punch 22.5 in the calculator and say equals to, you say it will say 45 over 2. Say 45 over 2. All right, but using half angle identities. So we said that if we have cos 1/2 theta, it will be equals to what? It's plus or minus into root of. So it was 1 plus cos theta, all divided by 2. That is the half angle identity proven. So please know how to prove so that you don't mix the sine half theta and the cos half theta. So therefore here we're going to have cos, as I said, it is 45, which was half, plus or is equals to plus or minus into root 1 plus angle theta, it is 45, all divided by 2. From there, our solution is equals to, we have root 1 plus, from the special triangles, what is cos 45? Cos 45, special triangles, if you have forgotten, refer to the notes. Written this down. So it's 1 over root 2, then all divided by 2. So in the special triangles, it's 1 over root 2. So please recall special triangles. Now I'm not using a calculator. So I'm adding the fractions in the numerator. We'll have root 2 plus 1, all divided by, let me write the root, all divided by root 2. So instead, let me write this this division. In this format, we'll have 2 divided by 2. So changing it to multiplication, we have root 2 plus 1, all divided by, changing this to multiplication goes to the denominator, it means with root 2. So we'll have 2 root 2 multiplies root 2. So please don't forget, in this denominator here inside the root, we have an irrational, what we call denominator, isn't it? An irrational number. I hope you see. Root 2 is what? Root 2 is it is an irrational number. So hence try to rationalize using 1 by applying root 2 over root 2, multiplying the numerator. So just an addition multiplied by root 2 over root 2. I want to get rid of that non-real, not non-real number, the rational number. That is equals to, so root 2 multiplies root 2, we're going to have 2. And root 2 times 1, we're going to have root, so root 2. Then over. So root 2 times root 2 is 2. Then 2 times 2, it is 4. So hence, if you simplify further, the answer will be equals to, the numerator shares the root, will have root of 2 plus root 2, all divided by root 4. Root 4 is, it is 2. Root 2, it is 2. So that's how we can simplify that without the use of a calculator, So hence, even if you try and use a calculator and prove, you still get the same answer, same ratios. I think we can conclude it here.